We've just seen how ESXi autonomously does a great job of ensuring that all of your virtual machines get the resources that they need. But when we as system administrators know better about how to prioritize in the event of contention virtual machine resources over one another, one virtual machine versus another virtual machine getting the resources, we have some options. And these come under the topic of resource controls. We're going to look at 3 different types of resource controls: shares, reservations, and limits. And in doing so, we'll define what these are, and we'll describe how virtual machines typically compete for resources and allow you to use these values of shares, reservations, and limits to actually change that around a little bit. So let's dive right in by looking at these 3 concepts. And we can look at these three concepts kind of by looking at the total capacity for CPU and memory of your individual virtual machines as we have allocated those resources to the VMs. So these reservations, limits, and shares, they apply most of the time to CPU and memory, but they also apply to storage IOPS as well as network bandwidth in the later versions of ESXi from 6.5 and then 6.7 and forward. But most of us are concerned mostly here with these CPU and memory concepts. So what is a reservation, what is a limit, and what is a share? Let's start with the actual allocation of, in this case, memory. We'll look at memory, okay? And we'll define this. If the total available capacity, say for example, is 8 gigs of RAM for your virtual machine, let's see if I can get the pen up here. 8 gigs of RAM for your VM, then by default, ESXi guarantees nothing to the virtual machine. All ESXi by default is ever doing is best effort. I'm going to give, if I possibly can, up to 8 gigs of RAM to this virtual machine. If I cannot give 8 gigs, if I can only give something less than 8 gigs, maybe I have to swap out instead. Fine. So the guaranteed minimum by default is 0 megabytes of RAM. Okay? Now, if we want to change that value, we can. We can tell ESXi to create a guaranteed minimum amount of resources to a virtual machine. And this is the concept of a reservation. I can guarantee any amount of memory up to exactly what I've allocated. Okay? Any other virtual machines that I haven't had a guarantee for, if we are under contention, will have to fight amongst themselves for the available resources. But if I set a reservation, it's a guaranteed minimum. Now here's the thing. Imagine I have, say, 64 gigs of RAM on my ESXi host. I want to guarantee 8 gigs of RAM to each of my identical VMs. What that means is that I cannot guarantee more than what I physically have. ESXi will not allow us to do it. And if we tried to do it, if, for example, I had 8 of these virtual machines, each with an 8 gig memory reservation, okay, fine, that's a total of 64 gigs of RAM. But if I tried to power on a 9th identical VM and there's no available guaranteed capacity left, then the VM will not power on, okay? So be careful when setting reservations, okay? Only set them on the virtual machines that you absolutely require that very minimum amount of available resources. Okay, So that's a reservation. We also have the opposite. If a reservation is a floor, then the ceiling is the limit. Okay, I've got a virtual machine with 8 gigs of RAM allocated, but I only want to allow it to access 2 gigs of physical RAM. After it tries to access more than 2 gigs of physical RAM, everything else goes to swap. That's the definition of a limit. That's the ceiling on physical resources. Now, by default, we don't place a ceiling. Therefore, the ceiling will be whatever the allocation would be. So if you look at the settings within ESXi, the default limits are infinity and the default reservations are 0. Now, anywhere in between the reservation at the bottom and the limit at the top, if your ESXi host is under contention, and only if your ESXi host is under contention, we have a value for shares that define a ratio that says what or how will my virtual machines compete against one another for that particular resource. So let's dive a little bit deeper into reservations, limits, and shares when it comes to CPU and memory. When it comes to allocating resources, and in this case, a reservation for memory, okay, keep in mind that memory reserved to a virtual machine is a guaranteed minimum, and therefore will never have to balloon or will never have to swap. And if an ESXi host doesn't have enough unreserved RAM, so I'll give another example. If I have a host with 64 gigs of RAM and I reserve 8 of that to a particular virtual machine, that's 56 gigs of RAM that is now unreserved or not reserved to other VMs. If a host does not have enough unreserved RAM to support a VM with a reservation, that VM will not power on. Reservations for RAM are measured in megabytes, gigabytes, or terabytes. The default is 0. Now, there's a setting in an in a virtual machine that says I can dedicate a physical PCI device to a virtual machine. Okay? We call this direct path I/O. This PCI device, this VM, and always this VM. If we want to do that, we have to guarantee all of the memory for that virtual machine. Okay? If you use direct path I/O, all 8 gigs of RAM for your VM with an 8 gig allocation will have to be reserved. Okay? And ESXi will tell you that through the vSphere client, and it'll say, do you want to reserve all the RAM? You say yes. And that'll allow you to do direct path I/O. So just a note about RAM reservations. When it comes to CPU reservations, okay, it's measured in megahertz or gigahertz. Okay, so I can guarantee out of my VM with 2 cores on a 4 gigahertz processor, all right, so that's 8 gigahertz of RAM, I can guarantee 1 gigahertz will always be available for that virtual machine. Okay? That means that the VM in question that I've placed a reservation on will never have to wait or compete against other VMs for at least that 1 gigahertz that I have reserved. Okay? We're introducing a new term here called CPU ready, and this is a very important term. CPU ready says that a virtual machine is ready to schedule a CPU thread, but ESXi doesn't have an available core on which to do so. So if CPU ready is anything other than 0, it means ESXi has had to place that thread in such a state that it is waiting for a core to become available, at which case it can schedule that thread on the core so that the thread can then be executed. CPU ready is a bad thing, okay? If you have a reservation set to a VM, at least for that portion that we've guaranteed, those threads will never be placed in a CPU ready state. Okay? The default for reservations for CPU, again, is 0. Now, limits are something that we don't often use, right? Because when we allocate a couple of vCPUs, and we typically don't want to tell ESXi not to use that, right? We don't want to tell ESXi, hey, don't allow that VM to use that RAM that we've allocated to it, okay? So we don't really recommend using limits, but the feature is there in case. An old DOS application, for example, probably doesn't need 4 gigahertz of CPU. And even though I've only given that DOS application 1 virtual CPU, it will actually consume all 4 gigahertz because DOS applications don't know how to idle. Okay, so in those cases, yes, maybe we'll do a limit. Okay, it's a technical reason within an application, right? So we can work towards that. But just know that when it comes to memory, anything that a VM requests beyond the limit that we set will go straight to swap. In terms of CPU, any threads that we want to schedule faster than the limit that we've set will actually have to go into a CPU ready state, and we will then prioritize those in the order that they're requested. So that's resource allocation limits.